Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 1 of University of Debrecen seminar number 4 in the subject of biostatistics. In this seminar, we are going to discuss the binomial distribution, the Poisson distribution, and we'll answer some of the examples. We'll start with the binomial distribution, or sometimes called Bernoulli distribution. Okay, so binomial distribution, from its name, is pi. Pi means 2. So it has an event which has 2 options only. Okay, either yes or no, A or not A, absent or not absent, gender, male or female, test positive or negative. Okay, so it is dealing exactly, there are exactly 2 outcomes in the outcome space. Okay, I have only 2 outcomes, either positive or negative. That's why even the subject here called discrete distribution. Discrete means I have limited option, like blood group A, B, A or B or AB or O, for example. If we throw a coin, so we'll have the head or the tail only. Okay, so we have discrete number of options. That's why it's called discrete distribution. But in binomial, I have only 2. Okay, it is not 4 or 6 or 7. It is only 2. So there are exactly 2 outcomes. If we have only 2 outcomes, it has to trick in our mind that it will be binomial or Bernoulli's distribution, okay, or Poisson distribution. So there are exactly 2 outcomes in our outcome space, the space of outcome, all the possible outcomes, all the possible output. If I did experiment, what all the possible output, head and tail, head, tail. So all the possible, either head or tail. For example, this is just an example. So this is called my outcome space. So the outcome space, the space which has all my possible outcomes. Okay, so event A and not A. This could be one of the outcomes, either A or not A. So it is only 2 options. I don't have third option. In our medicine sector or medical sector, we have many of the cases or many of the events where we have exactly only 2 options or 2 outcomes. Okay, many variables in medicine have exactly 2 outcomes. Okay, or they are called dichotomous. Okay, such as survival, either the people will survive or not survive, the gender, male or female, the test positive or negative, test result positive or negative, the gene present or not present or absent, disease present or absent. So I have many of the events in the medicine sector which has only 2 outcomes, okay, 2 potential outcomes. This binomial distribution has 4 properties, okay, and these properties we have to know them. For binomial distribution, each observation falls into one of the 2 categories. Okay, so either A or not A. So if the probability of A equals 0.2, so the probability of probability of A bar of not A equals 0.8. Okay, the other way around. Okay, so if the probability of A equals 0.7, so the probability of not A, which is A bar or not A, equals 0.3. So 1 minus 0.7, okay, equals 0.3. So the probability and its complementary, which is 1 minus, okay. So instead of calling A not A, so we used to have this 2 terminology P and Q. So P, the probability which I'm looking for, called B, the probability of B. And this is the probability of the thing which is favorable to me, and its complementary will be Q. So B, if I have the probability of B equals 0.2, so the probability of Q equals 0.8. Probability of Q equals 0.8. Okay, so I can say that Q equals 1 minus P. Okay, always it's 1 minus P, because the full probability is 1. And minus the probability P, I can get the probability of the complementary, which is Q. Okay, so here each observation falls under one of just 2 categories, only 2 categories, and it will be one of them, the outcome. Okay, let the probability of event A be signed by probability of A equals P, okay? So the probability of the event A will happen, called P. So the probability of not A, okay, will be called A complementary, okay? Not A means A complementary, equals 1 minus P, which is Q, because I have only two options, okay? So all the probabilities, okay, of happening and not happening, the sum of them should be equals to 1. There could be the other way if you can understand the first property, okay? So two categories, the sum of the probabilities is equals to 1. So if one of them, probability of thing happen is A, the probability of not happening, it will be 1 minus the probability of A. So if the probability of A is P, Q will be 1 minus P, okay? The number of observations are independent. What does it mean? They are independent. For example, I toss a coin, okay, and in the first time I got a tail. If I toss the coin second time, the first observation which I have, the first outcome will not affect the second time. So second time also it may appear a tail or it may come a head. So the first outcome does not impact the second time or the third time or the fourth time. So all of them could be tail, all of them could be head, or could be one time heel, one time head. It depends. So they are fully independent, okay? So my observation means the outcome. So the outcome of the first round does not impact the outcome of the second round. So the outcome of the third round does not depend on the previous outcomes, okay? So all the observations, all the outcomes are independent, okay? We cannot assume that because the first one come tail, the second no, still have the same chance, okay? Because if you throw dice, it may come one. Second time may come one again. Third time may become one again. They are totally independent. In our case, we have only two choices, like the coin. So if someone of the patient, the first one has the disease or tested positive, the second one may be tested positive. It doesn't mean that if the first one tested positive, the second one will be impacted. They are independent, okay? So in order to use the binomial distribution, I must have these 4 criteria. Okay, what are these criteria? I have only 2 categories, okay? My observation falls under 2 categories, okay? Like positive, negative, survivor, not survivor, male, female, positive, negative, presence, non-presence, okay? And I have to know that Q equals 1 minus P, okay? The probability of the complementary equal 1 minus the probability, the initial probability. The third thing, that the probability of a given outcome is constant, okay? So the probability of head always remains 0.5, theoretically. The probability of tail always remains, even if head appears 5 times, but next time when I come to throw it, it has the probability of 50%. After 100 times, the tail still have the probability of 50%, 0.5, okay? So the probability of a given outcome is constant over the trial. So if it appears 100 times, it does not change, okay? So here, the next observation or the next outcome does not depend on the previous. And here, because some people are confusing between these two. So here, the next observation is independent from the previous observation. If the first one become tail, the second one could also come tail, could come head, whatever. The probability percentage or the probability itself, it remains the same. If it is 0.5, it will remain 0.5 forever, okay? Constant. The fourth thing, that if I want to have an experiment using binomial or Bernoulli's distribution, I must, before starting the experiment, I must fix the number of trials. I say, okay, I have this experiment, I try it for 100 times. So I should not make it 101 or 99. I should fix it all the time, okay? I should not decide later on. So before starting, I have to set up the number of experiments, okay? The number of trials is fixed and is specified in advance. Before starting the experiment, I'll make the experiment 15 times, 16 times, 100 times, 200 times. So it should be fixed in advance. I should not, after find different readings or I get influenced or impacted by the readings, I decide to increase the number, maybe the answers or the observation will change. I should not change my mind. From the beginning, I have to decide how many trials I should have, okay? So if I have N, so you can call it BNK, okay? You can call it probability of K happening the number of occurrence, number of time the event will occur. You calculate B n k. Okay, so out of n trials, I want this to occur 3 times. So in advance, I agree. I want it to occur 3 times out of 100 times or out of 5 times or whatever. Okay, this another way. What is the probability of k happening? Okay, so there are different ways of writing it, whatever, but at the end of the day, you have to apply this formula. The formula says that n b n k, b, I have n total number of trials and I want k of them, or if the probability of k in the case of binomial, one of them only, it will be given one of them. Okay, not both of them, one of them, this or this, either one of them. It will be equal to combination NCR or NCK. Okay, NCK, in my case, N, okay, will be put here, and the K, NCK, the probability of P of the power of the second one, okay, K, and the Q, the new one, which I don't have. Always I have to calculate the Q in my problem, because P, the probability which I have in my problem, in my questions, okay? But Q, I have to calculate, which is 1 minus P, okay, equals the Q, okay? So, it's okay, NCK, P of power K, and the Q, it will be power of the minus, okay, N minus K, N minus K. Okay, I hope this one clear. Let me write it again so we can memorize it. So, PK, or you can call it Bernoulli's NK, will equal NCK P of the first P of K, okay, of power K, Q of power N minus K, N minus K, that's it, okay? So I know that NCK equals, so P NK or PK, as you like to call it, okay, will be equals NCK. NCK equals what? It will be equals N factorial divided N minus K factorial, okay, times K factorial, times K factorial. This is what? This is NCK. You remember? Okay, times P of power K, P of power K, Q of N minus K. Okay, and this is the formula. So now we understand from where this formula came. This is the formula which I want you to understand. So here, N factorial divided N minus K factorial times K factorial. This is N, okay, C, K, okay, times PK, P of power K, Q of power N minus K. There's another way of writing it, like the factorial. You remember we said the factorial, we can write it NCK, and also we can write it NK. So both are the same, NCK or NK, they are the same, okay? So here this means NCK also. So NCK, okay? It is the same thing, okay? Either this or this. I hope this is clear. So this was the probability, okay? So the probability, again, probability of K equals NCKP, the last one, K, Q, N minus K. I can write in different way, P, K equals N factorial. NCK equals N factorial divided N minus K factorial, K factorial, okay? Times PK, Q, N minus K. This is the formula, okay? So what about the mean or the average or the mean? The mean in this case will be N times the probability which I will get times N. This will be the mean. That's it. So the mean in this case, it is simple in binomial. It is just the probability, the mean is the probability times the number of occurs, of independent trials which I have, okay? The number of independent trials. So NP, this will be the mean, mu, okay? Or mean M. The standard deviation will be the same thing, NP, but just multiplied by Q. NP, Q. Standard deviation is more complicated than the mean, so we'll add Q and we'll put them under square root, okay? So NP will be the mean, if I multiply NP times Q also and put under the square root, it will give me the standard deviation, okay, ST or D, okay? So if I have a case in the discrete distribution, we're still in the discrete distribution, which have a limited number, two available occurrences could happen, okay? Two possible outcomes. So if I have the probability is very, very minimal. Like for example, if you assume the probability is 0.0002, for example, or probability 0.00005. It's very small probability, okay? In this case, I cannot use Poisson distribution, okay? If the probability is very small, except if I have large number of trials, large number of n, okay? So if n is very large, like 1,000, 150, 200, 1,000, even 100 is median, okay? It is a medium count of number of trials. It could be 1,000, could be 300, 500. Large number of n and the small probability in large and the probability very small. In this case, I can use Poisson distribution. So in Poisson distribution, there are a few things I need to know. You remember we said the mean, which is mu, and in the previous case we used to say x bar, okay, x bar or mu, one of them, okay. Here we will not have the mean or the average. We have something called the expected value, okay, the expected number or expected value, which is almost, you can call it the mean, okay. So expected value, expected number, sometimes they are calling it E or they are calling it lambda, okay. So lambda equals NP. You remember in the last slide, we have said that the mean equal NP. Here, the mean equals NP. The mean in this one equals NP. Here also the same thing. Lambda will be equals NP. Okay? Lambda equals NP. And lambda is called the parameter of Poisson distribution. This is its name. The mean, which is called lambda here, is called the parameter of Poisson distribution, and it is not a very small amount. I cannot ignore or neglect it. Okay, it is non-negligible. Okay, so the end of the story. I don't want to take you in the stories in this Poisson. So lambda is the expected occurrence in any event in this problem. For example, I do an experiment. I have an overall expected occurrence of any event, okay? So I say the expected occurrence is 0.3 or 0.7 or whatever. This is called lambda. Lambda is the expected occurrence. But if I have a specific event, okay, and I want to know the probability of it happening, okay, 3 times or 4 times or 5 times, so the expected number of occurrence on an event called lambda. So lambda is the expected number that it will happen. But what if I want it to happen 2 times, 3 times, 5 times? Okay, so this is called k, the number of times I expect it to happen. Remember that k also here was the expected number of time in the previous slide. Okay, k here, the expected number of happening here. Okay, the event occur and k times. So k, the number I want it to happen 2 times, 3 times, at least 5 times. And remember also, if I said at least 3 times, means it could happen 0 or 1 or 2 or 3. At least 3 means 3, 2, 1, 0. Okay, and we have already taken the way how to calculate at least before, and maybe if we find an example here, we'll come in touch with it. But this is not our point now. Our point now that lambda, okay, lambda is called the parameter of Poisson distribution, and lambda also is the expected number of occurrence of an event in this problem. So in every problem, we have the expected number. How we can calculate the expected number? Lambda equals NP. Okay, the number of the opportunities multiply the probability, which is very, very minor. We said the probability here it is rather unlikely to happen, very small probability. This is the Poisson distribution. I told you Poisson, we have very small probability but very large n number, okay? So here the Poisson, the event is rather unlikely to happen, so small probability, very small probability, but a lot of opportunity, n is very high. So if we multiply n by p, we'll have a reasonable number, which is not zero, it is not negligible. It is not zero, okay? It will be a bigger number because n is very high. Although p is very small, but n is very high. So lambda will have a value. That's why we call it expected what? Number of occurrences. Okay? So here, Poisson distribution, in the case that the event is rather unlikely to happen, a small probability, p is very, very small, but lots of opportunity, n is very, very high. N is very, very high. Okay, very, very high. Okay, 100, 1000, whatever. Okay, so in this case, I can say, okay, although this p is very, very small, 0.00005, for example, and n is 1000, for example, or 10,000, okay? So if I might multiply them in p, I'll get a number called lambda. This is called the Poisson parameter, okay? This Poisson parameter is the expected number of occurrences, okay? By multiplying them, the value will not be very small. The value will be little reasonable, okay? So it may be 5, maybe 2, maybe 3, whatever. Sorry, it will maybe 0.5, 0.2, 0.3, whatever. So I have a reasonable number which is not equals to 0. So this is the expected number of occurrence, lambda. Because if I multiply the large n by the small p, I get a reasonable number which is not negligible, non-negligible. Lambda equals np, okay? This is the only point I want you to know from here is lambda equals np. And coming to the law, how we can use this lambda and how we can find the probability. This is the law which you have to know for Poisson. So the probability of a k happening 5 times 3 times k times equals lambda of power k. So the k will be on the power here, okay? Lambda of power k divided k down. See, k here is down, k factorial, okay? So one time k will go as a power of the lambda, okay? And the other time k will go as the denominator, k factorial, and then times e on all your problems here for e power minus something, okay? E power minus lambda in this case, okay? So this is the law which I want you to memorize, okay? Pk, the probability of k event happening 3 times 5 times k times equals lambda of power k, okay, divided k factorial times e of power minus lambda. And in this case, the mean will not be the probability np, because I have already multiplied them and I get a new terminology or new unit called lambda. So lambda is np, so my mean will be lambda in this case, okay? Here it was np, n times p. Here it's n times p already multiplied and we get lambda. So my mean will be lambda, okay? And as you remember here, we said that, okay, if we take the square root of the mean np, but we multiply by q, we'll get the standard deviation, okay? So the square root of this one, just let me clear it. We said the square root of np, but just we multiply by q, then we got the standard deviation, okay? So standard deviation, we can get it from the mean here, just we multiply by q, as we said, multiply by q. It is the same thing, np, multiply by q under the square root. The same thing we can apply here, but without multiplying by q, because I don't have q in this case. I have only lambda, okay? I'm not using p at all. I'm using np just one time to arrive to lambda, and that's it. Then I use lambda. So the standard deviation will be the square root of the mean, okay? So the mean equals lambda, standard deviation, the square root of lambda, and that's it. I hope this one is clear. So this was the whole theory part of seminar number 4, and wish you all the best.